If you're one of the people who saw the Death Star destroying the planet of Alderaan with its super laser and thought, wow, I wish we had that in real life, you're in luck! The United Kingdom has spent a lot of time developing a laser weapon, and in just a few short years, we'll see it in action for the first time. Called DragonFire, this laser-directed energy weapon is admittedly still far from turning planets into space dust. No surprises there, but it's proven to be more than capable of destroying drones and missiles during its many field tests. Once we look past the sheer coolness of a laser weapon, though, when we scratch beneath the surface, the DragonFire system might be the herald of a warfare revolution, turning the focus away from traditional projectile-based weapon systems to cheaper, pound-per-shot weapons, turning the tides of attrition warfare into the favor of the owner of not the biggest, but the most economically efficient weapon system. How do laser-directed energy weapons work? Okay, before we get into the nitty-gritty of DragonFire's design, which is a very cool name, by the way, let's first take a look at laser-directed energy weapons and how they operate. As the term itself implies, these weapons use lasers. Yes, indeed. To inflict damage, or at the very least blind optical and guiding systems on enemy weapons such as drones and aircraft, while they can also be directed at the human operator specifically. This technology is, believe it or not that new. Directed energy weapons have existed since the 20th century at the very least, with Archimedes' legendary heat ray being the earliest mention of a directed energy weapon in history, albeit the reality of that weapon is often brought into question. According to the tale, Archimedes created a complex system of mirrors during the Roman siege of Syracuse and used said mirrors to focus the energy of the sun to set Roman ships on fire. It was of course found that this would be almost impossible, as the ships would have to be stationary for at least 10 minutes and the sky would have to be perfectly clear for the weapon to work. But the theory does check out. The Nazis then did their fair share of research in the field, developing a sonic cannon that used magnified sound to vibrate the middle ear bones and cause vertigo and nausea in people. During the Iraq War, American troops disrupted and destroyed Iraqi electronics by using high-power microwaves, not so dissimilar from the same microwave that you use to make popcorn, but on, steroids. The idea of using energy instead of a projectile to disable enemy technology and vehicles or even terminate troops has always been very much alive, but it seems like the 21st century is going to be the time when we actually see it materialize, which, when you think about it, should cause fear rather than hype, shouldn't it? DragonFire is going to be predominantly used against drones, missiles, and projectiles such as mortar and larger artillery rounds, or we can categorize it as an air defense system, although this is not final as we won't know its precise capabilities and applicability potential before it's revealed and used in combat. There were many attempts at laser weapons in the past, and the ones that worked in testing, including the DragonFire system, relied on fiber laser technology. And by the way, we're about to get into some pretty high-level physics, so put your thinking hats on. Every laser, which is essentially just light, needs a medium to operate, and fiber lasers use optical fiber, which is very fine glass fiber with integrated rare earth elements such as erbium, neodymium, thulium, and many other chemical elements that you saw on the periodic table of elements in school and thought were just made-up words. These elements are natural optical amplifiers, which means that they make the optical signal much stronger without the need to first convert it into an electrical signal. The optic fiber is an incredibly important part of weaponized laser design for several reasons. First of all, optic fiber is fairly flexible, making it sturdier and less prone to wear and tear. They also provide incredibly high output power in comparison to other laser mediums, supporting kilowatts upon kilowatts of power without a hiccup, and thanks to the fiber's high ratio of surface to area volume, it cools off easily and likely won't overheat. Finally, optic fibers are the best medium for laser weapons because they're particularly good at tackling thermal lensing, which is one of the two major problems stopping us from having the Death Star's super laser in real life. It's disappointing, we know. Thermal lensing is the formation of a thermal lens on the medium, in this case the glass, and it happens when the glass absorbs some of the radiation that heats up too much. The newly formed lens has focusing power of its own. It further diverges light, and put simply, it messes with the way the medium is supposed to focus the laser, because when it comes to lasers, even the smallest fractional indentation can throw the entire system off balance. High-performance lasers are comically precise systems that cannot afford even a picometer of irregularity. Optical fiber guides the energy in one direction, minimizing diffraction, and alongside some other properties, which are naturally classified, it's very good at minimizing thermal distortion, which in turn minimizes the chances of thermal lensing. This, however, is only one of the two big problems with laser weapons, with the other being thermal blooming. Thermal lensing and blooming are essentially the same processes, but blooming occurs outside of the laser's medium, i.e. after the beam leaves the optic fiber. Blooming happens when the energy density of the laser becomes way too intense, reaching around 1 megajoule per cubic centimeter. To paint a better picture of just how preposterously huge that amount of energy is in such a small space, imagine if you could shrink an adult male sperm whale weighing approximately 33 tons to the size of a sugar cube, and now imagine throwing that whale through the air at 100 miles an hour. First of all, congratulations, you are an incredibly strong magician, but more important than that, that's what 1 megajoule per cubic centimeter is. When that much of the laser's energy is densely packed in such a small area, ionization, the process of gaining or losing an electron, begins in the immediate area around that single cubic centimeter, and plasma begins to break down. Plasma, in case you need reminding, is the stuff stars are made of, including our sun. When this incredibly complex process occurs, the laser defocuses, and instead of focusing its energy in a single beam, it disperses it into the surrounding air. When the beam loses focus, it's not effective, and it won't be taking down any drones or enemy missiles, and this has, in fact, been the biggest problem with laser weapons over the past few decades. When the air is more dense, which happens when there's rain, snow, smog, dust, smoke, or fog in it, thermal blooming is even more common. However, if you manage to solve both of these issues, as the designers behind DragonFire seemingly have, you've got yourself a laser weapon capable of shooting down more or less anything. DragonFire's inception and design. The DragonFire system was first revealed in 2017 in London, and it was designed by a consortium of weapons and defense manufacturers. MDBA UK is a company specializing in missiles. BAE Systems is a leader in technology-led defense, working on the F-35 and the Eurofighter Tycoon, among other aircrafts. Kinetic is a leader in advanced control systems for all types of weapons. Leonardo is involved with so many different aircraft and drone projects, it would take a separate video just to list them all, and ARC is a leading project manager in the defense space. The exact details of DragonFire, they're naturally classified, but here's what we know so far. The laser is designed to defend land and sea targets from primarily aerial threats such as drones and mortar rounds, which it was tested for and passed with flying colors. The system itself is mounted on a turret alongside its targeting systems, with the laser being powered through tens of glass fibers. The targeting system is separated from the main laser doing the shooting, and it consists of an electro-optical camera and a low-power laser whose sole purpose is target tracking. DragonFire is reportedly in the 50 kilowatt class, but that should be taken with a grain of salt, because whenever the military says the maximum range of a weapon is X or that the top speed of an aircraft is Y, it's always guaranteed that both X and Y are much greater than what's officially known. This is a common practice among all the world's militaries, as it's not the brightest idea to let the enemy know exact capabilities of your defenses. The same goes for DragonFire. It likely outclasses 50 kilowatts, and since it was designed with power expansion in mind, we will almost certainly see its power grow. This is not just speculation. An official UK government press release specifically credits Kinetic as the company behind the phase-combined laser capable of generating 50 kilowatts of power, quote, with the ability to scale firepower levels in the future. 50 kilowatts is, of course, a lot of power. It could power close to 10 average American households without fear of blackouts. To have that energy at hand for DragonFire, the designers turned to the Flywheel Energy Storage System, which is a joint UK-USA innovation being developed at this very moment. The energy storage system works by spinning a rotor which keeps the energy in the system as rotational energy, proving once again that all engineering advancements will always come down to two things: finding more efficient ways of boiling water and using rotational energy. The most common use of a flywheel is inside a car's transmission, as it stores rotational energy when the clutch isn't engaged, transferring that energy back once you change gears. The issue with traditional flywheel systems is that they come with a trade-off. While they're great at energy storage, they can be incredibly heavy and bulky, with some rotors reaching 200 tons in weight, and as you might imagine, Navy would rather opt for a smaller solution just to minimize the weight impact on the rest of the vessels equipped with DragonFire. What makes FESS such a good fit is its use of lightweight flywheels. The flywheels rotate at a high speed, then slow down a bit when energy is released, and then speed back up again when energy is added. Andrew Tate, no, not that Andrew Tate, the Defense Science and Technology Laboratories engineer Andrew Tate, said that this type of flywheel system was actually developed by the Williams Formula One team, and after joint testing by the United States and United Kingdom, it was deemed as a great solution as it's very cost-effective, it's lightweight, and perhaps even more importantly, I can't stop thinking that Williams should maybe just focus more on race cars. It doesn't require the DragonFire's energy system to integrate into the ship that it's on. Another important part of the DragonFire is the command and control system, including the effector management system. Effectors, in military jargon, are any type of system that can affect a target's state. For example, there are some drones designed with the sole purpose of provoking a reaction from air defenses to cause anti-air batteries to reveal themselves. These drones are detection effectors. Relative to DragonFire, the integrated effector management system is going to determine how the laser will affect the target, detect it, deter it, disable it, or destroy it. This is a very important system function, as there's no need to use a hammer on a mosquito. Finally, when it comes to the actual firing of the laser, the general layout of the glass fiber suggests that light will be shone through tens of glass fibers in separate laser beams. This is a smart way of mitigating the thermal blooming issue that we discussed earlier. However, 10 small laser beams are going to have a weaker effect on the target in comparison to one powerful beam. It appears that the engineers have found a way of combining the beams, but the exact method remains a secret. What's not a secret, however, is the Israeli iron beam system, which uses essentially the same technology. Instead of focusing all of its power in a single beam, the iron beam shoots hundreds of small beams no larger than a coin. These smaller beams face less distortion individually, and when a beam hits a target, which is detected through the laser's integrated target detection and tracking system, all other beams focus on the same spot until the target is destroyed. We can observe the same philosophy with the US Navy's AN/SEQ-3 laser weapon system, otherwise known as LAWS. LAWS uses 6 lasers strapped together that also converge on the target at the same time, instead of focusing all of their energy into a single beam, acting as a short-range defense system against drones and boats. It seems that DragonFire is following the same strength in numbers methodology. First trials were supposed to take place in 2018, with the first major demonstration scheduled for 2019, but this little thing called COVID happened and the Earth stopped turning, delaying the trials until 2022. Then DragonFire proved it could track air and sea targets with fantastic accuracy, after which separate trials were conducted to actually fire the high-power laser. During these trials, and subsequent to aerial defense trials that took place in 2024, the DragonFire had to engage targets no larger than a 1-pound coin, which is about 23 millimeters, or just under an inch in diameter, from a kilometer away. The real accuracy of the DragonFire is, of course, classified, but it passed this examination with flying colors, and while the 2022 test took place on the legendary Portentown range with a maximum distance of 3.4 kilometers, that gives us a bit of a clearer picture of the DragonFire's capabilities. The targets it fired on were drones and metal plates, like the ones used in ship hulls, while it was also tested against mortar rounds and drones to great effect. Military application. So, happy with the test results, the Ministry of Defense decided to speed up the development and deployment of the DragonFire, investing more money in the program and pushing the delivery date from 2032 to 2027. Also, instead of developing just a single system and then making the decision on further development based on that single system's on-field results, the ministry secured additional funds to develop 3 more DragonFire systems. At the same time, Connecticut, one of the leading developers of the system, started working with Australia on the development of a similar system, implying that the DragonFire is a success that validates further interest from allied nations. But the question remains how the UK will use the system, and in turn, how are laser weapon systems generally affecting battlefields. It's planned to mount the DragonFire and other similar systems which may be developed in the future aboard Royal Navy warships, specifically on a Type 23 frigate, the Army's armored vehicles such as the Wolfhound, and the Air Force's fighter aircraft, including the Tempest, a 6th-generation aircraft we won't get to see for another decade. In all 3 configurations, sea, ground, and air, DragonFire Dragonfire will serve as a defensive weapon, not an offensive one. When mounted on a frigate, the laser will work alongside other missile and projectile-based systems to protect the vessel. It's highly unlikely that Dragonfire will ever completely replace traditional projectile-based weapons for several reasons. First of all, weaponized lasers still don't have the capacity to destroy a target momentarily. Sure, a laser of such immense power could light a piece of paper on fire or destroy a tiny drone after just a millisecond of contact, but if a missile or a military-grade drone were launched at the frigate, the laser would need to stay on target continuously for at least a few seconds in order to burn through its metallic armor and neutralize it. It's also important to note that war technology always evolves in response to enemy capabilities, and most drones and missiles would be covered in a layer of heat-resistant coating before being launched at a vessel protected by a heat-based weapon. Furthermore, if the smoke, fog, or a chemical obscurant dispersed on purpose by the enemy to mitigate the laser threat, required on-time target could be even longer. In this regard, traditional projectile weapon systems have a huge advantage. While they can be affected by the atmosphere, they're not nearly as vulnerable to it. If you fire a missile at a drone and it reaches the target, the drone is destroyed in spite of rain or fog. The second reason Dragonfire won't be replacing traditional defense systems is its range. The general rule of thumb with laser weapons is that if an enemy missile isn't in the visual range of the laser, it can't be taken down. This is, once again, a problem you simply don't have with old-fashioned interceptor missiles. As soon as the vessel's defenses detect a drone, a missile can be dispatched to intercept and destroy the drone well beyond visual range. For the same reason, it's unlikely you'll use the Dragonfire to destroy an incoming intercontinental ballistic missile. First of all, it's unlikely an ICBM would ever travel low enough to get in Dragonfire's range, but even if it did, when you blow up an incoming ICBM, you generally want it to be quite far away from the protected area. For this very reason, there is currently a lot of development of laser systems capable of taking down targets within hundreds of kilometers, which would apply not only to ICBMs, but also aircraft and low-orbit satellites. Dragonfire, however, is not designed for this purpose. Laser weapons, however, have two huge advantages in comparison to projectile-based systems. The first one is price. The Ministry of Defense claims that firing Dragonfire for a single second costs no more than a single pound, and given that it would have to stay on target for about 10 seconds to take down a drone, downing a drone would cost no more than £10. For the same price, you get a burger in New York or 100 square millimeters of an apartment in London. For comparison, the missiles used with the Sea-Scepter missile system aboard the Type 23 frigates cost about £2 million per unit, which is 200,000 times more expensive. So sure, using the Dragonfire comes with a set of caveats, but the system is so ludicrously cheaper than traditional defense systems that the risk might be worth the price. If it were to be used against Iran's Shahed drones, which are also produced by Russia, it would be incredibly economically efficient, as the production of a single Shahed drone costs between $10,000 and $50,000. Dragonfire could shoot down 1,000 of them, and its ammo expenditure would still not reach the price of a single drone, which would make the launching of Shahed drone swarms an act of economic insanity. The second advantage Dragonfire possesses is the ability that it comes with virtually unlimited ammo. Type 23 frigates are equipped with 32 cells containing the aforementioned anti-air Sea-Scepter missiles, which is fairly constricting. Lasers, on the other hand, can fire forever, at least in theory. Drone operators are aware of this limitation, which is why drones almost exclusively attack in swarms and are very rarely seen taking individual action. Laser weapons are a good answer to this threat. They allow the ship to conserve its missiles. When used in combination with existing air defense systems aboard frigates, this innovation turns into a very useful layer of additional protection in a world where attrition warfare is becoming the norm. When it comes to mounting the Dragonfire atop a Wolfhound armored vehicle, it would also serve as an air defense weapon, and once again in cooperation with traditional systems. The only documented instance of an anti-air laser engagement, at least at the time of recording, was actually the use of Israel's Iron Beam system in October 2024 against Hezbollah's UAV swarm. The footage of the attack was released 7 months later, and according to both the footage and post-action reports, the Iron Beam intercepted around 40 UAVs. The Ministry of Defense, however, stated that no Iron Beam components were used, implying that there's a light version of the system, and that's what we see in the video. Either way, that engagement can serve as a case study of how Dragonfire might operate in a terrestrial configuration. It could serve a similar purpose on combat aircraft, including the Tempest. It's a cheaper, limitless alternative to air-to-air missiles, which could be particularly useful in non-emergency scenarios in which the pilot has enough time to down the target slowly. The revolution brought on by laser weapon systems goes beyond what meets the eye. For example, the persistent issue with traditional weapons is that aside from carrying the weapon itself, the operators also have to transport the ammunition too. Bows need arrows, assault rifles need magazines full of ammo, artillery guns need truckloads of shells, and frigates need anti-air, anti-ship, anti-submarine, and sea-to-land missiles. Entire logistic chains are built around these weapons, and DragonFire might shake up the system. Although it's not as fast or effective at destroying big, well-armored targets, it's, for example, highly unlikely to so much as dent a tank, it's more than effective enough against thinly armored or unarmored targets, providing it has enough time on target. At the same time, it's logistically a low-maintenance weapon that takes a huge weight off logistic officers' chests. DragonFire might become the first major case study of how laser weapons affect military strategy, because the UK is seriously considering deploying it in Ukraine. In 2024, the UK's former Secretary of Defense, Grant Shapps, announced that the system might be sent to Ukraine as it's a win-win situation. The UK gets its newest weapon field-tested, and the Ukrainians get another anti-air system to help combat the invasion from the east. Shapps said the DragonFire, quote, didn't have to be 100% perfect in order for Ukrainians to get their hands on it, and the system was, quoting again, designed not to wait until we had it at 99.9% perfection before it goes into the field, but get it to sort of 70% and then get it out there and then develop it from there. This implies that DragonFire was designed with future modifications in mind, leaving room for battle-tested improvements and changes. The Russia-Ukrainian war has proven so far that mobile air defenses are incredibly useful, and that's exactly what DragonFire could bring to the table. But at the time of recording, the system has not yet reached Eastern Europe. Once DragonFire has strength in numbers, mobile units will be able to form a protective perimeter that will make life exceptionally difficult for drones, which have so far defined the two most intense ongoing conflicts, the Gaza and Russia-Ukrainian wars. Taking drones down will become much cheaper than it is currently, and in a war of economics, something we covered in detail in the recent video we did on the Shahed drone, currently used by Russia, DragonFire is a sure winner. With subsequent development of more powerful lasers, ones capable of quickly downing not just drones and missiles, but fighter aircraft and satellites, the focus of warfare will be brought back on land. In order to avoid laser fire, aircraft will have to fly low, which limits their armament loadout and burns more fuel, and it will force major manufacturers to focus on stealth. Some designs, like the legendary 8-end Warthog, which is essentially a flying tank, are going to become obsolete, as they'll simply be too vulnerable to systems such as the DragonFire. Attack helicopters are going to be put in an ever worse position, as they're slower than combat planes, and have to get well within the range of a laser system to deliver their payloads, forcing commanders' hands to prioritize tanks, infantry, and artillery to clear those targets first. It's also possible that, in response to this, we'll witness the horrific development of DragonFire-like weapon systems designed specifically to take out human targets, which are, after all, unarmored and much easier to take out than drones and missiles. Such powerful laser systems, however, they're not here yet. They're predicted to enter late-stage development sometime in the next decade, and although they'll far outmatch the DragonFire and similar systems in range, speed, and sheer power, they will very much walk on a path laid by the UK's newest laser-directed energy weapon. Finally, although it's highly unlikely that laser weapon systems will ever make traditional projectile-based weapons entirely obsolete, we're currently witnessing a minor revolution in warfare that could take us in a never-before-seen direction. Thank you for watching.